It was one of the haunting and bewildering images of the Christchurch earthquake. The CTV building in a pile of smoking rubble, while others all around it were still standing. 115 people died in the collapse, and their families demand to know why. Well, tonight, one man's theory. He's a professor of engineering, and he's critical of the original design of the CTV building. What's more, he reveals aspects of the design had been questioned right from the start. John Hudson with the story.
Oh my God!
Oh, shit!
Oh my God, that's the CTV building!
In a field just outside Christchurch lies the remains of a dead building. Twisted and rusting steel, broken concrete. It doesn't look like much, but for engineers, this paddock holds the secrets to New Zealand's worst ever natural disaster. Of the 181 people who were killed in the Christchurch earthquake, most died here in the smoke and rubble that was the CTV building.
I was just a mess, and another earthquake hit in the church. Things come down. We can't find Nina. No sign of Nina.
Viv Bishop is one of hundreds still grieving.
So this is Nina?
Yep.
Yeah.
Her beloved Nina gone in an instant. Nina had been an administrator with relationship services on the 5th floor.
And I miss her so much. I just wish she was here. She was my best friend as well as my daughter.
Condolences help numb the agony, but Nina's death and the ongoing quakes have made Viv's life hell.
Over it, tired, ready to move on. Nina's baby.
For months now, Viv has been asking, why did Nina die? Why was this building totally flattened?
Something in the structure was not sound anymore for it to come down like that.
And she isn't alone.
Personally, yeah, it's a hellhole, really.
Brian Kennedy lost his wife Faye, practice manager for the clinic on the 4th floor.
It's just a big hole to fill, and it's taking quite a bit. And I think
Brian and his family had spent much of that night in the nearby park hoping and praying.
we're realists, but you had to look at the crumbly mess and say, good God, if she made it through that, we're very, very lucky. Darkness was coming, it was drizzly. There was a helicopter with a monsoon bucket trying to attend to the fire, but obviously there were people trying to rescue people, wasn't that many, and the others were taken to the morgue.
People had serious concerns about the general safety.
Today, Brian's part of a group of people whose relatives died in the collapse. People who now want answers.
It's rather weird, isn't it, that the clinic people, CTV people and others have mentioned that when vehicles went past, it shook. You don't normally get everyone agreeing and wanting to tell you that.
This is where the CTV building stood until 6 months ago when it collapsed, killing 115 people. All that remains today are unanswered questions. Why did this building collapse when others like it of the same vintage, even older, are still standing? Was there something structurally wrong with the CTV building? And if so, how did those faults get through the council inspection and consent process? And are there other buildings that are disasters waiting to happen? When you look at the vacant space where the CTV building once stood, you can't help but wonder why it collapsed when the IRD building across the road seemingly escaped without a scratch. So Sunday went back to the drawing board, to the 1986 plans for the CTV building, and we discovered, even back then, a council engineer questioned aspects of the design. Then we took the drawings to America to get an independent analysis. San Diego, California. It seems like an unusual place to be trying to figure out why the CTV building collapsed in the Christchurch earthquake. But we've met a man here, a professor of engineering, who figures that he's got the answers. My journey has brought me to the Charles Lee Powell Structural Laboratories, to Professor Jose Restrepo. He spent his life making buildings safer in earthquakes, including 15 years studying and teaching at the University of Canterbury.
Appears to be a column here.
Professor Restrepo inspected buildings after the Christchurch earthquake. The central city, he says, was hit by a massive vertical force that no one ever dreamed of.
The intensity of the movement felt in downtown Christchurch was way more than what we had designed buildings for.
But from the air, it's clear that while the CTV building was flattened, other buildings around it are undamaged. Could the design of this building have been a factor in the collapse?
There is no reinforcing bar coming out from the wall into the slab, okay?
Professor Restrepo studied the CTV drawings. They confirmed his suspicions.
You have the lift shaft here that stood up, and you have the floors of the building, okay? These floors and the lift shaft need to be connected, okay? Because if in the case of an earthquake, these slabs have accelerations, and those accelerations with the mass, they produce forces. Those forces need to be taken back to the wall, to the lift shaft. In the CTV building, when we look at the drawings and the spot checks, we do find some critical areas.
The first critical area, he says, is the way the floors are tied to the lift shaft, using in places welded steel mesh.
And those connections are rather precarious. They are precarious. And in a way, there were many buildings in that era had these kind of connections as well.
Why is the steel welded mesh precarious?
Because it just fractures. It has no ductility.
This is welded steel mesh, similar to that used in the CTV and other buildings of the time.
So this wire mesh, what you see here, is very brittle. Very brittle. It just takes a little pull and it snaps.
And this is how it ended up. Mesh was often used inside the concrete floors, and in the CTV building used in places to tie the floor to the lift shaft.
The lift shaft provides a lot of the stability, or the lateral stability, the lateral strength of the earthquake resistance to the building.
And it was later discovered the mesh can be brittle.
So it actually bonds very well to concrete. So when the concrete has to move, the mesh has to follow. It doesn't have the deformation capability and it breaks.
It snaps?
Yeah, it snaps.
And that, Jose believes, is what happened. The mesh snapped.
It ripped off of the lift shaft and the building then went down.
The evidence of what happened, says Professor Restrepo, has been in front of us all along.
You can see the lift shaft here. It stayed like it had never been connected to the building itself. So the building implodes and spills over a little bit.
How do you feel about it?
Yeah, shocked.
In the CTV rubble, the broken steel mesh still clearly visible. Back then, when this building was constructed in 1986, did the use of steel mesh to tie the walls to the lift shaft breach the building codes?
No, it is not at all in breach of the code. No, it's one of the things that we say is one of the potential deficiencies of the code. In research we did in the early 1990s, we recognized that welded mesh was a very bad thing. So there were changes made to the code. I think the code has been updated for this.
However, even before construction on the CTV building began, the City Council had written to the design engineer asking for more information about how the floors would be tied to the lift shaft.
Because the stability of the building depends to some extent on those connections. So they requested the design engineer for further information about that type of connection.
Do the council records show they got that information?
Not in writing that we know of. Yeah, the only way I can think is that perhaps they, on a phone conversation, they explain that, but there is nothing in writing.
After the break, what happened to the columns?
The columns could have exploded in compression and rendering the building useless, pancaking the building.
It's Professor Restrepo's job to discover what happens to buildings in earthquakes.
So this is the actuator, the ramp that moves the shake table. So it reproduces the movement of the ground
He does this by shaking the living daylights out of full-sized buildings with these massive hydraulic rams. Right now they're constructing a 5-story building just so they can shake it to pieces and then set it on fire. This is how he and colleagues discovered in the early 1990s that welded steel mesh can be brittle and snap.
And you can see, for example, there is not a single connection here, not a single connection in this.
Using aerial video of the remains of the CTV building, Professor Restrepo showed me where he believes the welded steel mesh simply snapped off the lift shaft.
So totally disconnected from the backbone, if you like.
And Professor Restrepo believes there was also a problem with the columns.
The columns could have exploded in compression and rendering the building useless, pancaking the building. What I can see from the photos, the building has not spilled to the parking lot or to the street, has basically imploded.
In Professor Restrepo's opinion, there simply wasn't enough steel to hold the columns together. The columns in the CTV building were confined by a coil of just 6mm steel rod spread at a pitch of 250mm.
What is surprising here is that the columns have just very little confinement. So it's like the weightlifter that doesn't have a bend here and is about to take that load and it bursts.
Professor Restrepo believes the vertical force from the earthquake first lifted the building, and when it fell again, the lower columns exploded.
It's a terrifying story for that building.
How does he know this? Well, the lab in San Diego is continually testing column designs like this one.
We have coil, and this is a 12mm coil, more or less at 45mm pitch.
So is this how the columns should have been built in the CTV building?
Yeah, in a very similar manner, not identical, every column may be different, but in a similar manner.
In a simulated earthquake, the steel prevents the column collapsing. So the steel is thicker and it's banded closer together, is that right?
It is indeed.
Yeah.
In the CTV building, we'll see a little bar here, and then again, we'll see another one here.
Right.
Yeah? So the pitch was extremely wide.
Amongst the rubble of the CTV building, beams, mesh, but we could find only one round column. The thin coil mangled, the concrete gone. The floors imploded, the columns exploded.
That's the hypothesis.
And everything fell over like a stack of pancakes.
Oh my God, that's the CTV building. Oh my God.
We wanted to know if the structural engineers who designed the CTV building agree with Professor Restrepo's hypothesis. Alan Ray Consultants were the structural engineers for the CTV building built back in the mid-80s. The principal of that company, Dr. Alan Ray, told me he's not prepared to talk on camera at this stage about the design. However, Professor Restrepo told me that he believes the CTV building did meet the building code of its day, although it would not meet today's codes.
For engineering assistance, where extensive building damage is observed and a rapid assessment, level 2 is to be undertaken.
The process of inspecting buildings after the September and Boxing Day earthquakes has also been criticised. Was the CTV building safe enough to be reoccupied? Well, relatives of those who died believe that long before it collapsed, the building shook oddly every time a truck went past.
It could also mean that during the first shock, the building slightly detached from the lift because the welded mesh may have fractured.
And that might explain what Viv Bishop saw.
On both sides of the elevators there was cracks up the wall, and on the right there's a little window, and when you looked out there you could actually see a crack down the building.
Her daughter Nina had been worried.
After the Boxing Day one, she didn't feel that safe in there really. She'd talk about the shaking and the shuddering of the building.
Did anyone say, look, we think this is an unsafe place to be?
It was mentioned to the owner of the clinic, but he assured everyone that it was quite safe, and I think CTV staff will say the same thing.
The CTV building was checked 3 times by council staff. 3 times it was given a green sticker. But the council engineers didn't even inspect the inside of the building. However, as Mayor Bob Parker points out, a green sticker doesn't automatically mean the building is safe.
It's not considered to be our job to go in and inspect every single building right down to that nth engineering degree. That's the responsibility of the person who owns the building.
Soon after the Boxing Day earthquake, Nina Bishop's employer, Relationship Services, contacted the building manager. They were deeply distressed about new cracking. They say the manager assured them the building was safe, claiming he'd already had an engineer inspect the building after both the September and Boxing Day quakes. The CTV building manager denies that he made that claim to Relationship Services, but Relationship Services are adamant that he did. The manager told us he'd planned to get the engineer back in following the Boxing Day earthquake. But 8 weeks later, when the building collapsed, that hadn't happened. Professor Restrepo believes it would have taken an experienced engineer with access to the building drawings to spot danger caused by broken steel mesh. And even then, the task wouldn't have been easy.
You may have spotted something that you want to recheck, but I think it's pushing for what we normally do.
Now that we know what can happen, do you think that the stickering process, the way that buildings are inspected in future, should change?
Yes.
The CTV building collapse may act as a wake-up call for building owners, not just here in Christchurch, but throughout the country.
The things we learn here need to be applied very widely, and they will change the building codes in New Zealand. They will change the building codes in many places in the world. Let's not get complacent. It could happen to you.
Ideally, says Professor Restrepo, buildings should be monitored electronically, in the way that modern cars and aircraft are monitored.
We should be able to deploy sensors to look at what the building did during the earthquake and after the earthquake, and see if we capture signals of distress that warrant a more refined inspection.
And building drawings should be stored electronically, so they're easily accessed in an emergency. But perhaps the biggest lesson to be learned from the February quake is also staring us in the face. That even though this was one of the most powerful forces ever to hit a city, most modern buildings, those designed to withstand powerful earthquakes, are still standing, thanks largely to the work of people like Jose Restrepo.
Modern buildings are standing except for a few. Some may have to be demolished, but people are alive. You can rebuild with new techniques that allow you to survive the next earthquake.
CTV design engineers Alan Ray Consultants say they too were horrified by the tragedy and are working with the Royal Commission to establish the cause. And if you have any information or thoughts of this story, we'd love to hear from you. Do get in touch Sunday at tvnz.co.nz.